Good afternoon, everyone. I am Dr.satyabrata, MDDM clinical pharmacologist, and today I am going to discuss on non-parametric tests. We will discuss on introduction, assumptions of parametric and non-parametric tests, testing the assumption of normality, commonly used non-parametric tests, applying tests in SPSS, advantages of non-parametric tests, disadvantages, and lastly summary. Coming to introduction, what is a variable? Variable, a characteristic that takes on different values in different persons, place, and things. That is dependent variable or independent variable. Then coming to what is data. Data is the measurements or observations of a variable that can be nominal, classificatory, that is gender, for example, gender, ethnic, color, blood group, frequency, and proportions, ethnic background, and eye color, and ordinal, that is ranking, for example, school performance, social economic class, level of satisfaction, 357 point Likert scale, frequency, proportion, sometimes mean. Then another is interval scale of quantitative or parametric, for example, Celsius or Fahrenheit scale, mean, median, standard deviation. Another is ratio scale, quantitative or parametric, Kelvin scale, for example, Kelvin scale, pulse rate, respiratory rate, the mean, median, standard deviation. Interval or ratio scale may be discrete or continuous. Then parameter. Parameter is any numerical quantity that catalyzes characterizes a given population or some aspect of it. Most common statistics parameters are mean, median, mode, standard deviation. Coming to assumptions, the general assumptions of parametric tests are the populations are normally distributed, follow normal distribution curve. The selected population is representative of general population. The data is in interval or ratio scale. But in case of non-parametric tests can be applied when distribution is free. Data don't follow any specific distribution and no assumptions about the population are made, and data measured on any scale. Then testing normality. For normality testing, this assumption is only broken if there are large and obvious departures from normality. This can be checked by inspecting a histogram, skewness, and kurtosis. Kurtosis describes the peak of the curve, and skewness describes the symmetry of the curve. Kolmogorov-Smirnov KS test sample size is more than or equal to 50. Shapiro will test if sample size is less than 50. Significant value more than 0.05 indicates normality of the distribution. Then for testing normality, normal. If it is normal, then use parametric, and moderate skew, use parametric. Then severe skew, use non-parametric, and in this case there is uniform, so use non-parametric. Normal plus outliers, use non-parametric. So commonly used tests. Commonly used non-parametric tests are chi-square test, the sign test, Wilcoxon sign reaction test, McNemar test, Mann-Whitney U or Wilcoxon rank-sum test, the Kruskal-Wallis or H test, Friedman ANOVA, the Spearman rank correlation test, Cochran's Q test. Coming to chi-square test, first used by Carl Pearson, simplest and most widely used non-parametric test in statistical work, calculated using the formula chi-square is equal to summation O minus E bracket square divided by E. O is observed frequencies, E is expected frequencies. and Carl Pearson is from 1857 to 1936. Greater the discrepancy between observed and expected frequencies, greater shall be the value of chi-square. Calculated value of chi-square is compared with table value of chi-square for given degrees of freedom. The application of chi-square test, comparison of categorical variable, test of association, smoking and cancer, treatment and outcome of disease, vaccination and immunity, test of proportions, compare frequencies of diabetics and non-diabetics in groups weighing 40 to 50 kg, 50 to 60 kg, 60 to 70 kg and more than 70 kg. The chi-square for goodness of fit determine if actual numbers are similar to the expected theoretical numbers. Then attack rates among vaccinated and unvaccinated children against measles. This is an example of chi-square, and here the in attacked rates and non-attacked, in case of vaccinated observed attacked with measles 10 and not attacked 90, and unvaccinated observed attacked 26, or non-attacked is 74, and total is 100, and total attacked is 36, total non-attacked is 164, and this prove protective value of vaccination by chi-square test at 5% level of significance. Then this is the group vaccinated expected and unvaccinated expected value. Attacked is vaccinated 18, unvaccinated is attacked is 18, not attacked in vaccinated is 82, not attacked in unvaccinated is 82, total is 100, and total attacked is 36, total non-attacked is 164. Then chi-square value is calculated is equal to summation O minus E square by E, and after putting all these values found to be 8.67, and calculated value 8.67 is more than 3.84 expected value corresponding to p value is 0.05. So null hypothesis is rejected and vaccination is protective. Again, chi-square test Yates correction applies when we have two categories, 1 degree of freedom, used when sample size is more than or equal to 40 and expected frequency of less than 5 in one cell, and subtracting 0.5 from the difference between each observed value and its expected value in a 2 into 2 contingency table. Chi-square is equal to summation O minus E minus 0.5 square divided by E. Then coming to Fisher's exact test, used when the total number of cases is less than 20 or the expected number of cases in any cell is less than or equal to 1 or more than 25% of the cells have expected frequencies less than 5. This is the person Ronald A. Fisher, is from 1890 to 1962. Then coming to McNemar test. McNemar test used to compare both before and after findings in the same individual or to compare findings in a matched analysis for dichotomous variables. For example, comparing the attitudes of medical students toward confidence in statistics analysis before and after the intensive statistics course. This is the person McNemar. Then coming to sign test, used for paired data, can be ordinal or continuous, simple and easy to interpret, makes no assumptions about distribution of the data, not very powerful. To evaluate H0, we only need to know the signs of the differences. If half the differences are positive and half are negative, then the median is equal to 0, H0 is true. If the signs are more unbalanced, then that is evidence against H0. The sign test, children in an orthodontia study were asked to rate how they felt about their teeth on a 5-point scale. Survey administered before and after treatment. How do you feel about Your teeth, wish I could change them, don't like but can put up with them, no particular feelings one way or other, I am satisfied with them, consider myself fortunate in this area. These are 5-point Likert scale. And child, rating before and rating after the values are given. Use the sign test to evaluate whether these data provide evidence that orthodontic treatment improves children's image of their teeth. Then the change was calculated, and first for each child compute the difference between the two ratings. Then sign was given to the change, and the sign test looks at the signs of the differences. Minus 15 children felt better about their teeth plus difference in ratings. One child felt worse, difference. 4 children felt the same, difference equal 0. If H0 we were true, we would expect an equal number of positive and negative differences. P value from table 0.004. Then coming to sign test, frequencies, rating after minus rating before, negative differences, positive differences times total, and rating after less than rating before, rating after more than rating before, rating after is equal to rating before, test statistics, the exact 2 tailed 0.01, test binomial distribution used. Then coming Wilcoxon sign rank test, non-parametric equivalent of the pair t-test, similar to sign test but take into consideration the magnitude of difference among the pairs of values. Sign test only considers the direction of difference but not the magnitude of differences. This person is Wilcoxon. For example, compare the effects of two sporific drugs. Each subject receives drug 1 and drug 2. Study this question: is drug 1 or drug 2 more effective at increasing sleep? Dependent variable difference in hours of sleep comparing drug 2 to drug 1. H0, for any given subject, the difference in hours of sleep is equal, likely to be positive or negative. Then the tables is given, signs and ranks will be calculated. Then Wilcoxon sign rank test was done, and it was found that Z value minus 2.312 and significance assumed 0.21. So like this the Wilcoxon sign rank test was done. Then coming to Mann-Whitney U test. Mann-Whitney U similar to Wilcoxon sign rank test except that the samples are independent and not paired. Null hypothesis, the population means are the same for the two groups. Rank the combined data values for the two groups, then find the average rank in each group. Then the U value is calculated using formula U n1 into n2 plus na into nx into nx plus 1 by 2 minus rx, where rx is larger rank total. To be statistically significant, obtained U has to be equal to or less than this critical value. For example, an example can clarify better. Consider the following samples. Sample A, observation. These are the observation values, these are rank values, and sample B, observations. The observation, that is rank values, and U here is, hence total is 80.5, n1 is 7, n2 is 9, hence U is equal to 7 into 9 plus 7, 7 plus 1 by 2 is minus 80.5 is equal to 10.5. Then coming to Mann-Whitney test, and in this way the test was done. and 10 dieters following Atkins diet versus 10 dieters following Jenny Craig diet. Hypothetical results: Atkins group losses an average of 34.5 IBs and J. Craig group losses an average of 18.5 IBs. Conclusion: Atkins is better. Question mark. So in this way Mann-Whitney U test can be done. And when individual data is seen, Atkins change in weight is find out, and change in weight in IBs also find out. Then Jenny Craig diet, this is image, and Atkins diet image, and Mann-Whitney U test rank the values, 1 being the least weight loss and 20 being the most weight loss. Atkins, J. Craig, these are the values, and sum of Atkins ranks, then sum of Jenny Craig's ranks was found out, and Jenny Craig clearly ranked higher, calculated U value less than table value, so 18 is less than table value 27, null hypothesis rejected. Then coming to Kruskal-Wallis one-way ANOVA, it is more powerful than chi-square test. It is computed exactly like the Mann-Whitney test, except that there are more groups, more than 2 groups, applied on independent samples with the same shape, but not necessarily normal. Then another test is Friedman ANOVA. Friedman ANOVA, when either a matched subjects or repeated measure design is used and the hypothesis of a difference among 3 or more K treatments is to be tested, the Friedman ANOVA by ranks test can be used. Then Spearman rank order correlation used to assess the relationship between two ordinal variables or two skewed continuous variables. Non-parametric equivalent of the Pearson correlation. It is a relative measure which varies from -1 perfect negative relationship to +1 perfect positive relationship. This is the person Charles Spearman. Is from 1863 to 1945. Then Pearson correlation evaluates the linear relationship between two continuous variables. A relationship in linear when a change in one variable is associated with a proportional change in the other variable. Example, Pearson correlation to evaluate whether increases in temperature at your production facility are associated with decreasing thickness of your chocolate coating. Spearman correlation evaluates the monotonic relationship between two continuous or ordinal variables. Variables tend to change together but not necessarily at a constant rate. The Spearman correlation coefficient is based on ranked values for each variable rather than the raw data. Spearman correlation is often used to evaluate relationships involving ordinal variables. Example, to evaluate whether the order in which employees complete a test exercise is related to the number of months they have been employed. Then Cochran's Q test. Cochran's Q test is a non-parametric statistical test to verify if K treatments have identical effects, where the response variable can take only two possible outcomes coded as 0 and 1. And this is the table showing the treatment 1, treatment 2, and treatment K. And in this way Cochran's Q test is done. Applying the test in SPSS software. Applying the test, the non-parametric in SPSS software, these are some. First of all, we have to find out the normality tests, and that is shown in the SPSS. Here, analyze the data. We have to put the data, analyze the data according to what test is applicable. Then chi-square test done in SPSS. This is the data showing the chi-square test, and this is the in SPSS sign Wilcoxon and McNemar test you can do from the SPSS, and Mann-Whitney U test you can also apply according to the data, and in SPSS Kruskal-Wallis H test can also be done, according to the data. Friedman's, ANOVA, and Cochran's is also found in SPSS. Spearman's row correlation test can also done from SPSS. Then coming to advantages of non-parametric tests, these tests are distribution free and easier to calculate and less time consuming than uh, parametric tests. When sample size is small, can be used with any type of data. Many non-parametric methods make it possible to work with very small samples, particularly helpful in collecting pilot study data or medical research working with a rare disease. Then coming to limitations of non-parametric methods, statistical methods which require no assumptions about populations are usually less efficient. As the sample size gets larger, data manipulations required for non-parametric tests becomes laborious. A collection of tabulated critical values for a variety of non-parametric tests under situations dealing with various sample sizes is not readily available. The summary table of statistical tests. Categorical nominal chi-square, one sample chi-square, rank or ordinal chi-square, one sample for one sample. Parametric, in case of parametric, you can do Z test or T test, interval and ratio. And in case of two sample, if it is independent data, then categorical nominal chi-square, rank or ordinal Mann-Whitney U, and parametric T test between groups. And two sample, if dependent data, then McNemar test in case of categorical or nominal, the rank or ordinal Wilcoxon sign rank, and in case of parametric T test within groups. And if there is case sample that is more than 2, if it is independent, then in categorical nominal chi-square, rank or ordinal crucial Wallis H, parametric is one way ANOVA between groups, and if it is k sample and dependent, then categorical nominal Cochran's Q, and rank or ordinal Friedman's ANOVA, parametric test repeated measure ANOVA. And in case of sample character, in case of correlation, and in case of rank or ordinal, can do Spearman's row. In case of parametric, it is Pearson's test. So this is the summary table of statistical tests. You can go through different articles and books to learn more and more about these statistical tests. Thank you very much for watching and subscribing my channel. And you can learn more and more from my channel if you watch from the beginning to the end of these videos. And also you can go through different articles, books to know more and more about these topics. So that's all for today, and Merry Christmas to all of you. Stay safe and enjoy the Christmas night and the Christmas. Enjoy the Christmas. Merry Christmas, Happy Christmas to all of you, everyone. Thank you very much. Jai Jagannath.